So keeping in mind the place value chart that we saw with the last video, consider the number made from 2 consecutive digits to the right of the decimal point, such as the number 0.37 or 37 hundredths. To change this decimal number into a fraction, we would write it as a whole number and place it in the numerator. So in this case, I'd put 37. That would be the numerator. Then use the denominator that corresponds to the farthest digit to the right that is being included. So for 0.37, the 7 is the farthest to the right, and that is in the hundredths column. So 0.37 can be written as a fraction as 37 over 100. Let's look at another way to change the fraction into a decimal number. By saying the name of the fraction, we can determine how to write it as a decimal number. For example, 27 hundredths is 27 hundredths. This tells us that the digit farthest to the right is in the numerator of the fraction, would be the digit in the hundredths place. So 27 hundredths tells me that the 7 should be in the hundredths place. And that gives us the 0.27. So change the fraction or mixed number into a decimal number. Well, in words, that number we have here is 51 thousandths. So 0. I would figure out where the thousandths place is, and that's where the 1 is going to be. And then the 51. So this is going to be 0.051. 17 and 9 tenths, well, the 17 and then the decimal point. 9 tenths tells me that my number should be in the tenths place. So 9 should be in the tenths place. This becomes 17.9. For the number 0.3791, the 1 is farthest to the right, and the 1 is in the 10,000th column. So 0.3791, written as a fraction, is 3,791 10,000ths. For the number 0.750, the 0 is farthest to the right, and that 0 is in the thousandths column. So 0.750 is, as a fraction, is 750 over 1,000. Notice that I can drop that 0, and I end up with 75 hundredths. I can also reduce it to 3/4. So 0.75 is the same thing as 3/4. Is equivalent. So change each decimal number into a fraction or mixed number in lowest terms. So 0.0048, this is the tenths, hundredths, thousandths, 10,000ths. So this is going to be 48 over 10,000. And then I could divide everything by, say, divide by 4. So this will become 12 over 2,500. I can divide by, say, divide by 2 again. That's 6 over 1,250. Okay, I can divide by 2 again. And I end up with 3 over 625. All right, 4 and this is in the tenths, hundredths, thousandths place. So this is 4 and 72 over 1,000. Again, this divide that fraction by 4. So I end up with 4 and 18 over 250. Which, again, if I divide by 2, this becomes 4 and 9 over 125. And the last one is in the hundredths place, so this is 85 over 100. I can divide the top and bottom by 5. I end up with 17 over 20. To write a fraction as a decimal, just use long division to divide the numerator of the fraction by its denominator. So 3/4, I would start off with 3, and 4 does not go into 3, so let's try 4 into 30. That goes in 7 times. So let's add another 0. 4 goes into 20, 5 times even. Now, the decimal of your quotient should match up, or the decimal of your dividend should match up with the decimal of the quotient. So the decimal points line up. And so we end up with 0.75 for 3/4. For 4/5, I'll put it over here. Whoops. So for 4/5, I would have 4, and I'm cutting into pieces of 5. Well, 5 does not go into 4, but 5 goes into 48 times even. All right, so 4/5 is the same thing as 0.8, 8/10. 3/16, I would have 3, and I want to divide it into 16ths. Well, 16 does not go into 3. There's the decimal point. 16 goes into 30 once. And 114 left over. Bring down to 0. And then try to figure out how many times does 16 go into 140. And I would say 8 times. 8 times 6 is 48. And 8 plus 4 is 12. So this comes out to be 12 is remainder. 16 goes into 120. It looks like here. 5, 6, I guess 7 times. 6 times 7 is 42. Or, yeah. And then 7. Okay, that's going to be remainder 8. So that comes out to be 112. 120 minus 112 is 8. And then bring out another 0. 16 goes into 80 5 times even. So 3/16 is the same thing as 1,875 10,000ths. Sometimes when we're finding a decimal equivalent of a fraction, the division process never gives a remainder of 0. In this case, the result is a repeating decimal. So repeating decimals can be written with 3 dots at the end, such as 0.444 ... Repeating decimals can also be written as a bar over the repeating block of digits. So 0.444 ... The 4 is being repeated, so I put a bar over the 4. So 5/12. I would have start with 5 and divide it by 12. And you keep going until you see a pattern. So 5 does not go into 12, but 5 goes into 50 4 times. That'd be 48 with 2 remainder. 12 goes into 20 once. That's 8 remainder. 12 goes into 80. What do we say? Well, 5 would be 60. 6 would be 72. So I guess 6 times. So that's 72. And now we have this repeating 6s. So this becomes 0.41 and then 6 repeating. All right, as for 7, start with 1 and divide it by 7. Again, 7 goes into 10 once, 3 remainder. 7 goes into 30 4 times, 2 remainder. Bring down another 0. 7 goes into 20 twice, 6 remainder. And bring down. 7 goes into 60 8 times, 4 remainder. 7 goes into 40 5 times, 5 remainder. 7 goes into 50 7 times, and I end up with a remainder of 1. And so now I start repeating. So 7th is going to be the 142857 repeated forever. Just kind of a note, 7ths are arguably one of the worst fractions to convert to decimals, and that you need 6 different digits to complete the pattern. But there is an interesting pattern that does appear. The same sequence of numbers shows up in any fraction with 7 as a denominator. So if you see the 142 is 7, 2/7, there's the 1/4 at the end there, and 2857. For 3/7, there's the 1, and then 42857. 4/7, there's the 1428, then 57. 5/7, there's the 14285, and then 7, and then 142857. That sequence of digits always repeats.